Yeah. I don't think there is a no. You lose a point if you don't say yes. There's a nothing. Yeah, just lie and say you're here. Yeah, sorry. All right. One. And by the way, you can also wait for me to tell you the answers if you want an option. Do the quiz. Or look at the quiz, think about the quiz. I'll tell you the answers, I guess. I think the front projector is, yeah. All right, there's a quiz. Do the quiz or look at the quiz. I'll give you the answers in a second. Yeah, it's true. So there was an executive order from the Biden White House actually last year that was interpreted as the federal government not being allowed to write in C anymore. I think there might have been I haven't followed the news. There's crazy stuff going on. It might have been rescinded. Anyway, doesn't apply to Canada as of yet. Okay. So yes, so the quiz first, and we'll then we're a little bit behind, although we're still more than 2 weeks out from the project two, not the online lab, the project one, sorry, deadline. So I'm really hoping to be able to wrap up what we need for the project tomorrow, and then we can start working on project one as well as the online lab, which you should do right now. It's really fast. And I apologize. I am behind on emails and stuff. I'll really try to get things together. So okay. Yes, so the correct answer for question one is that yes, you're here. This is a mistake, so please say that. Okay, so what is the correct way to print the value of n? So you could, of course, just directly print n. That's not one of the options. Why is this? Sorry. You can look there. All right. So you can, of course, also directly print 10, but the point is, oh, okay, there is a typo here. But anyway, the most correct thing, if PN is the address of, so this should be in star PN, of course. So the most, but nevertheless, like PN is the address, like it would still, like it would give a warning, but still. So P of n is the address of n. So in order to get the value at the address of n, you need to do star Pn. So let me just quickly edit this. Sorry about that. Yeah, this interface is terrible. So this is, of course, in star Pn, like so. So the options here are, so Pn here, that's the address of n, right? So this is the memory cell where n is stored, but that's not the value of n itself. Star Pn is the address, is the value, sorry, at the address Pn, which is the 42. So that's the correct answer. What is this? Is this a valid number at all? Anyone? Yeah. Yeah, it is a valid value, right? So this is the address where Pn is stored. So Pn has to be stored somewhere, and address of Pn is where it is. It's not 42, it's not the address of n, it's the address where the value Pn is stored. Yes.
Just like that's a question, but if we print long decimal versus decimal, when it's like if we have a longer integer and we do decimal instead of long decimal, what would happen?
So the question was like, if you do this, what's going to be printed? The answer is not necessarily anything that makes sense. And the issue here is what C does is it gets the value here, and then you tell it interpret it as if it's a decimal. If it's not actually a decimal, then it's not necessary. So depending on the value, it's not actually going to print the right thing. All right. So we'll get into it more later. So essentially, what you're saying is like, here's the value, and pretend it's a decimal. So okay. So what is the correct way to print array at 1? So what are the options here? So what is array plus 1? Array plus 1 would be the address where the 5 is stored plus 1. So this would be the address where the 6 is stored. So not the 6 itself, but the address where it is stored. Does that make sense? So the way it works is when you say, when you use a name, that's the name of an array that gets converted to the address of the first element. So array by itself is the address of the 5. And then plus 1 means move to the next address. So array plus 1, it's a number that exists. That number corresponds to the address where the 6 is stored. Questions about this? All right. What about this? Is that a valid number? Anyone? Yeah. Yeah. What's the number? Yeah, it is actually 6. It's just a different 6, right? So it is a valid number because star array means go to the address where the first element of array is stored and get the value. So that would be the 5. And then it just computes 5 plus 1. Right? Does that make sense? So this is different. This is saying compute array plus 1. So get the address of the 6. And then star that means get me the value at address array plus 1, which happens to be 6. So both of those in this particular case happen to compute 6, but in different ways. Does anyone not see that? All right. The fourth option is not really something that makes sense, right? Because we're saying address of, but here it's not the address of a variable. It's the address of a quantity. Can't really do that. At any rate, that's not what we want. Make sense? So the correct answer is C or 3 or whatever it is. All right. Okay. So that's that. So what I want to do to just something on Discord. Should I submit the quiz now or wait till you're done editing the quiz? I mean, I haven't done editing the quiz, so. And the quiz was valid before as well. Like, okay. So, okay. So I want to do a few quick things that you might need, and then move to some new stuff and then do some exercises. So one useful function is realloc. So what you can do with realloc is essentially you can give it an old address of a block. So for example, here you have a block that's of size 100. And if you decided in the middle to say, oh, actually, I need this block to be 200 in length, you can use realloc. So realloc gets the old address and it returns a new address of a new block that's of size 200. If it's necessary, so it might be that you can just extend the current block and say, well, it officially was 100, but there is space there for 100 more. So I'll just keep it where it is. If you do need to move it, which it might be, because it might be that there's no space at the end of the current block to store new stuff. If you do need to do that, it'll move it as necessary. Yeah.
You have data stored in the old block. Will it pass it?
Yeah, it will copy. So it will copy the old data. Otherwise, you could just like, you could just malloc a new block. The whole idea is, yeah.
Yeah, just taking the stuff stored in a malloc and reallocating it to a bigger malloc.
So kind of. So it's returning the address of a new block that has the same contents where you can store this many bytes rather than this many bytes. All right. And if necessary, it'll move it and copy stuff over. If not necessary, it will just return str back to you and keep track of the fact that now you're supposed to be able to store 200 there. Yeah.
Will it free the block?
It will free the old block. Yeah. All right. So one thing that you might like to do is error checking. So it might be that if you request too much memory, then it's just not possible to allocate a block that's large. So this is actually kind of modest. So here we're requesting, I guess, so 10 million bytes. So that's 10 megabytes. You can probably do it. But, multiply it by a couple thousand and you might start getting problems, right? So if that happens, then malloc will just return null. And what you might like to do is, instead of just crashing when you would try to access elements of the block or try to write stuff to the block when really block is null, you might like to check that the block is null. So what to do if it happens that malloc returns null? Well, at the level where we are working now, there's not much that you can do other than exit. So you might imagine that if you're writing a big application, right? So like you're writing like Microsoft Word or something, and you are trying to allocate a block for kind of whatever it is. You might like to say, okay, like maybe I've requested too much. Maybe I'll prompt the user to request less if it's something that's under the control of the user or something like that. So there might be situations where you don't just want to crash. If you're writing a simple program and you really needed this amount of space and malloc said can't do that, then probably what you want to do is just crash gracefully. The alternative is, if you're not checking, the program is just going to crash randomly when you're trying to access an element of the block that you're not allowed to access because block doesn't actually exist. Yeah. No. So return one inside. So the question was, is exit the same as return? the answer is no. So exit terminates the program. Return just returns from a function, right? So what is true is that if you're returning from main, that's kind of the same as exit. But ordinarily, you're not inside main. Ordinarily, you're inside some kind of function that's not main, right? Yeah, again, kind of why do that? So unclear what to do, right? So you presumably needed that block of memory, you didn't get it. So the best you can do is not to crash somewhere in the middle of the program where you're trying to start using block. It might be that you could display an error message, something like that. Right? Does that make sense? All right. Should you do error checking? So like I haven't been doing error checking in the examples I have been doing up until now, and I won't always do it going forward either, because the point of doing examples in lectures is not always to write a complete program that's ready to ship, right? At the same time, if someone who's not you is using the program, if you don't do error checking like that, so if you don't check whether malloc actually returns the right value, what's going to happen is it's going to crash and nobody's going to know why. So here, at least, you kind of gracefully said, well, like the problem is that you were out of memory. You might print something more elaborate than that as well. If you don't do that, it's just going to crash. You are not going to know why. So yeah, that's, yeah. I wanted to, wait, did I move? Yeah. So I wanted to do an example like this. Why didn't it change? Okay, anyway. Let's say that what I want to do is allocate a string that I can then use. So I'm going to show this to you, and I'm going to retype it in VS Code in a second. So what's the idea here? The idea is maybe what I want to do is have a function that basically gives me a string that I can work with, right? So when would I use something like this? For example, I want to get input from the user, like for example, their name or something. Before I do that, I want to be able to store the name that the user is going to give me somewhere. So this is one way to do it, and I might like to do it inside a function, and I might like it to be the case that the error checking is outsourced to the function. So what I'm doing here is I want to be able to pass str, the address of str, to the function, so that inside the function I am, assigning a value to str, and then that value is the address of a valid block of characters. So let's redo this in VS Code. Later. So the idea is I want to be able to say I have my string over here, and then I want to create the string. And then I want to be able to like put something in that string. So I don't know, like put in my name. All right. So, okay. So how would this work exactly? So first of all, in order to be able to modify str, it's got to be that I'm sending in the address of str to the function. Does this make sense to everyone? So this is the same as with integers. If you want to modify the value of a variable, it's got to be that you're sending the address of that variable to the function, right? So that means that it's got to be that I'm sending address of str so that I can make str So does that make sense to everyone?
Why are we passing the echo?
Right. So str itself is a pointer. That is true. And if what I wanted to do I could just pass str, right? So I could say, hey, like here's the address, go to that address, change, the first element at that address. In that situation, totally, I can pass str. But this is not what I want, right? I start out with str being just nothing. And I want str to become a valid address. So I want to change str, I want to change this rather than something like str0 or str1, right? So that's the distinction. Does that make sense to everyone? Okay, is this good? Okay. So, all right. So since what I'm doing here is I'm passing address of str, it's got to be that the type here is car star star. Why? Because str is of type car star. So that's this guy. Right? And this is star address of str. So the types have got to match. The type of str is car star. So the type of address of str is car star and then another star. Yeah? Questions? All right. So now what I want to do is stdlib, by the way. So now what I want to do is create a string and do error checking. So to just make sure that it was actually able to create the string. So I'll say star pstr is this. Let me put in the size here as well. So what's going on here? So on the left-hand side, I'm saying star pstr. Why is that? I want to be able to change str. So I think one way of thinking about it is just logic it out, right? So the logic here is I want to change the value of str. I'm sending the address of str to pstr. Well, in order to get back to changing str, I'm saying go to the address at str and change the value there. So that would change str. Another way of thinking about it is to just think back to the simplest example, right? So change integer works like this. So that's like the kind of the first example that we did with pointers. And you call it using change and address of x. And that's the same thing. So it's just that here we started with str being of type car star, whereas here we would start with x being of type int. Right? So send the address. If you want to change the value of x here, you are wanting to change the value of star px here. Similarly, you want to change the value of str. That must mean that you want to change the value of star pstr. This is just the standard thing. So this is how we allocate the block, right? So this is the type of the block. So pointer to car, and you call malloc. So that's the usual use of malloc. Right. And now we'll just do some error checking. So I'll say, if pstr is null, So download more RAM is like a joke. So RAM is of course like the physical thing, but sometimes people anyway, yeah.
Why is it PSTR not star PSTR?
Why is it yes, it is star PSTR, I think. Yeah, so that was a typo. So yeah, so we do want to say, you know, is PSTR, is it a valid address or is it null? If it's null, you just say, okay, out of memory, and then exit. So here, what you can do is you can try to use it. And this would be str. And here we'll return 0. So here, just kind of to show you what's going on. So it printed Mike over here. So the idea is that if I request like an unreasonable amount of memory, then what's going to happen is it's going to say out of memory, download more RAM. And that would be better than the alternative, which is not checking. So if I just ignore this, and if I run this, so what's going to happen? Well, it just crashed. So that's worse because it didn't say what was the problem. It just crashed. Now, when you're debugging, VS Code is going to actually like drop to the line which caused the problem, which is strcpy, because strcpy tried to write to str, which was null. There was a question somewhere. Anyone? All right. We heard the Discord chime. Yes, this should be block. Yes. Thank you. Where's this from, by the way? Oh, that's from before. Yes. Oh, sorry. This should sorry. Okay. So no, this is different. So so block here is of type char star. So the value of block is either null if malloc didn't return the right thing, or the value of block is the address of the block that malloc allocated. The difference is that here we are assigning the address to star PSTR, which is the same as assigning the address to str. And then over here, when I'm checking, I'm saying, was the value that got assigned to star PSTR, was it null or was it something else? Right? So that's the same as asking, does that make sense? So that's the difference. The difference is basically here I said star PSTR because I wanted to change str over here. And then I'm just asking, is star PSTR actually null or not? Yeah.
Hypothetically, what if you didn't have enough space in your memory for null?
The question was, what if I didn't have enough space for null? So there is it could happen. This is actually, if you're familiar with the website Stack Overflow, that's what it's actually named after in a way. So there is a difference though. So malloc is a function that you call and it tries to find a space in memory where it can store stuff. If the function was successfully called, then the spaces for all the local variables were already pre-allocated. So if the function is running, that means that there is already space. So local variables are stored in something called the stack, which could overflow, meaning that you ran out of space there. That could happen, the computer could crash, but the way it would appear is that you would not actually be able to call the function rather than, oh, I can't store the null, because the null is stored in the local variable PSTR. If the function was called, then there is space.
If there was no space, the function wouldn't be called.
I mean, the thing would crash. So like it is possible, right? So it is possible that you're trying to call the function and there's no space anywhere to store the local variables. There's details there that I'm kind of skipping over, but essentially it's that. And then at some point, the thing would just crash if you're out of space that way. Yeah.
Does null address?
Okay, so those are two different questions. So the question was, does null have a type and an address? Null does have a type, which we haven't explicitly talked about. The type is void star, so that's like a generic pointer. Does it have an address? No. So it's in C, you only have values, right? So in Python, you do have, for example, maybe you're thinking about none or something, which is an object with an address. C doesn't work that way, right? So everything is just a value. So in the same way that if you say, 0, which in fact is the value of null, or if you say null, those are just values. If you say something like a equals 0 or a equals null, that means, copy the value 0 to a, copy null, which is also 0 to a. So they don't have, so their values, they do not have addresses. Of course, if you say a equals null, a has an address. But null by itself is just a value, not anything that's associated with an address. Yeah.
So this null value is different from the null here, correct?
No, they are actually, so they're so like we're using them kind of interchangeably because they have the same value in practice. They all are actually equal to 0. But yeah, like we're using, because they're equal, we're using them for both of those things. Yeah, just stretching. Okay. All right. So that's like that. So okay. So questions about, I guess, create string. Okay. All right. So is there something in Discord? How do we access the online lab? So Piazza. What is that? Okay. Okay, you can try that. Okay. So, okay. So I wanted to kind of point out that like you can think about this as a kind of like dimensional analysis in physics, right? So you can think about, like if you need to send address of str to create string, then it must be that this is of oops. What did I do? Sorry about that. Then it must be that this is of type car star star, right? Because str is, what's going on? Because str is of type car star. So address of str, car star star, the types must match. So you can think about it as, if this has to be address of str, then it must be that this is car star star, because str is of type car star, and this is address of. So kind of like this. I have this hobby horse about dimensional analysis in physics being kind of fake news. I don't know if people tell you, but like, so like you have this, like law of gravitation, you have Coulomb's law that works like this, and of course, like the only reason they work is because the constants G and K have those completely fake units so that the dimensional analysis works, right? Like there is no physical, completely true. There's no physical reason other than to make the units match that the gravitational constant would be like, you know, Newton meter squared, whatever, and Coulomb's constant would be this. So just saying. So, okay. I will not be taking questions about that. So I want to do kind of, before we move on to examples, I want to talk a little bit about strcat. So I'll just implement strcat, and then I'll do kind of a re-implementation of strcat, which is kind of traditional. So like you need to see it, even though it doesn't really arguably make sense. So first of all, what does strcat do? So you've all done those examples in the lab. So it concatenates. So cat stands for concatenate, which means just put together str1 and str2. So in C, ordinarily all those functions are hyper optimized in the sense that they don't even check if there's space at the end of str1. Not that there is a way to do that ordinarily. And if there isn't space in str1, if you did not take care to do that, then what's going to happen is the computer is just going to crash. So we are going to implement it the normal way for now. Stop. So strcat returns the just by kind of the specification, it returns the pointer to str1 back. So I'm making it be const car star because while you should be multiplying the contents of str1, you should not be multiplying the contents of str2, and that's kind of the usual definition here. So with just a for loop, what we're going to do? So I could, of course, call str length because I need to put str2 at the end of str1, but I want to be kind of efficient about it and just go through str1 once. So I'll just define I be 0 initially. And I'll say, so while str1 at I is not equal to null, I'll increment I. So to remind you, that's the same as I plus equals 1. And now at this point, str1 at I is null. So can start writing contents of str2. So I'll do another variable. And I'll say while str2 is not null. Okay. Okay, and I advance both I and J. Sorry, str1. And there's one more thing that's left. What's left? Anyone? What? Yeah. Say again? Oh, yeah, I already did, right? So I'm writing to str1. Yeah. Yes, but before that. Yeah. Exactly. Yeah. So I'm missing a null at the end of str1. So I copied all the characters from str2 to str1, but currently str1 is not a valid string because there might not be a null at the end. So I'll just say str1 at I is equal to null. All right. Is that making sense? So every string needs to be terminated with a null, and I haven't done that. So why is this str1 at I? Well, because I wrote the last character, str1 at I equals to str2 at j, and then I advanced I by 1. Yeah.
Instead of like incrementing I and j.
Yeah, totally. I could, yeah, I just thought that's the simplest way. Yeah. All right. Questions about this? Does that make sense? So again, kind of as you're starting with this, it makes sense to, think about types and stuff. So this is kind of very standard. And I think even with like the 2 labs that you've done, you're already used to it with like, like this is a string is char star. The way you access element in the string ordinarily is like this. So that should make sense. I think this might be a little bit confusing. So this is supposed to return char star. So what does it mean about what you should return here? Well, str1 is of type char star, so that's good. All right, so you can just check, well, like str1, what's the type here? Well, the type is char star. Again, like by tradition, people write it like this, but really this is the type, and this is the thing that's returned. It's char star. Yeah.
So instead of writing the null character, we can write null.
You could just write 0, or so like people write like this sometimes, or they write like this, or they write like this. They're all equal to 0. It's all fine. All right. So okay, I have 6 more minutes. I'll try to show you kind of the plus stuff. So it's a little bit of an aside because I don't think that you should often use this kind of stuff. At the same time, you see this kind of stuff in code all the time, so you need to know about it. So plus, when not used in an assignment, so an assignment means like, assign the right-hand side to the left-hand side. It's just the same as plus equals 1. However, when it is used in an assignment, it's a little bit weird. So the way it works is it has an effect. So you can say something like b equals a plus plus. The effect is that a gets incremented by 1, but also the value of a plus plus, the thing that gets assigned to b, is the old value of a. Okay, so the effect of b equals to a plus plus is b is the old value of a, so b would be 42, and a gets incremented after you do the assignment to b. Or not necessarily after chronologically, but that's what happens at the end, is b has the new value, a has the old value, b has the old value of a. There is also a plus that's it's called prefix as opposed to postfix. You don't need to know those terms. So prefix is the other way. So what happens is the new value of b gets assigned to c, and also b gets the new value. So in this case, b becomes 43, and also c becomes 43. Make sense? Okay. So you can use this kind of stuff for kind of something like strcpy, strcat, that's kind of more concise. So to remind you, saying something like star str2 equals star str1 is the same as copy the first element of str1 to the first element of str2. You can combine this like this, right? So you can say, I want for this to happen. So I want the first element of str1 to go to the first element of str2. And I also want to increment str2 by 1 and increment str1 by 1 after the assignment happens. Make sense? So with that, let's write an strcpy. So we could write it, the normal way. All right, this is source. So that's the same kind of thing, right? So, and then again, dest I is null. And we return destination. But then, so does that make sense to everyone? So that this should be kind of straightforward now. But then I could say, well, like instead of using I, what I can do is I can say, okay, so I'm just using dest and src, and I'm gonna keep advancing dest and src. So I'm gonna say while src is not equal to null, so I can do it kind of like this. And that's equivalent. Does that make sense? So what I'm doing is I'm just like, instead of using I, I'm just going to say, I'm going to copy start src to start dest, and then I'm going to advance dest and advance src. Yeah.
Because their addresses.
Yeah, exactly, because they're addresses. And then I see I have just 1 minute left. You can do something even more annoying. And instead of saying this, so I see that I'll have to do it next time. I can say star dest plus plus equals to star src plus plus. And be done with that. Because that's the same. And then also, if I wanted to be really annoying, I could say while star src without not equal null, because and again, that will have to wait until next time, because star src is non-zero exactly when it's not equal to null. So I can just say while star src. And then I don't even need the brackets because that's a one-liner. So yeah, so that would work. Okay, all right, I will see you tomorrow. Bye. And I'm going to argue with people on Discord about dimensional analysis, I guess. Okay.
I have a question.
Yeah.
Can you turn on the code again?
Yeah.
Yeah. Like,
Yeah.
like here you said like it's const src, okay, but like why you can change it?
I'm not changing src, I'm just changing dest. Oh, I see what you're saying.
But
So, yeah, because if you remember, so the way it works is const for star means you're not allowed to change the contents, but you are allowed to change the value. So if I said const
So
star
so
const, then that would be.
Oh, okay, so you can change like the
Yeah.
like the pointer SRC.
Yeah,
but you're
so,
not allowed
yeah,
to change,
yeah,
like,
yeah, so
stuff
it-
that's pointing.
Right, so it's like, so if you remember, it's kind of like this.
Oh, yeah. Oh, yeah.
So this means you're not allowed to change the value of S1. This means you're not allowed to change the contents at the addresses.
Okay, yeah.
I see. Or if I have a code like star h is equal to something, star h plus is equal to something, then it means that h get the value first, or h plus.
Do you want to
plus
type
the-
in the code that you're asking about? Because I can't really do it by ear.
So I mean just star maybe h plus is equal to something.
Yeah.
And then it means that h get the value first, or h plus one first, and then get the value.
So plus, oh, sorry, let's just go out.